All right, there are two ways that we can check this particular data set for outliers. There's an inefficient way, which is how we typically use z-scores actually. And that is, as we looked at each of these values, we would probably make a z-score for each one. So we'd be like, okay, let's make a z-score. We might want to use the largest value to test because that's the most likely thing to be an outlier, the largest and the smallest. So we'd be like, okay, our z-score, that's 150 minus my mean, which was a 125.38, all divided by that standard deviation of 22.63. All right, so I'm going to go ahead and do this in my calculator, and I'll let you see. Calculator's huge, though. Let me resize her so she's on the screen. All right, so you do not, by the way, need this calculator at all for this class. You can just use the internet, type this into Google. You could use Desmos. It has a lovely calculator. Um, in fact, this calculator is actually going to make this a little bit harder to do because I need to make sure that I either do this in two steps to make sure that the grouping happens appropriately for the order of operations. Um, oops, 3.8. But I'm going to make sure I have parentheses so that it knows to do the numerator first and then divide that whole value by 22.63. Um, all right, so the z-score for the highest price of the wine is only 1.09, which is definitely not unusual by our criteria. We're using a 2 standard deviation or z-scores of greater than magnitude 2 for our criteria. So, okay, well, the biggest wasn't an issue. Let's look at our smallest value. It appears our smallest value is that case price of $67. So, okay, let me try that. In fact, we've already seen this data set. This was in an old video. I don't remember if I gave it to you for making modified box plots. But here she is again. All right, so mean and standard deviation stay the same, but this time our observation that we're making a z-score for is 67. So I'm going to go ahead and just bring back what I just typed, which would be more convenient if I had a real calculator with this is less. All right, and I'm going to change this to 60. 7 and then delete that extra value. Now I have a z-score, I should have written the other one down, of negative 2.58. So this one, oops, negative 2.58. So based on a criterion of 2, this is an outlier. This is more than 2 standard deviations away from the mean. So it would be unusual. It's outside that 95% of the data that we would be guaranteed if this was actually a normally distributed data set. Doesn't look to be. We don't know anything about that. So, but it's still outside that 75% we would expect by Chevyshev's rule as well. This is an inefficient way, as I was saying. A cleaner way to do this would be to actually, since we have more than one and we're asking if anything is an outlier, would be to create that sort of those cutoffs, make fences essentially, like we did back with our box plots and back when we looked at Chevyshev's, and just go, okay, well, the mean is this. So 125.38 minus 2 times our standard deviation of 22.63. Let's just figure out what that is. 125.38 minus 2 of our standard deviations, 22.63. That is 80.12. Oh God, I didn't want to go that way. Oh, I did. I did. The high one was an outlier. The low one was. Okay, I went the right direction. And then look and be like, is there anything less than 80? Thankfully, the next smallest value is 90, which is not less than 80. So we have a single outlier here at 67. But had there been more than one, we would have been calculating. I mean, theoretically, we would need to calculate the z-score for 90 as well. Rather than just have one calculation to kind of create that fence like we saw before. But yeah, so this is evaluating outliers using z-scores. We did this once when I worked at UCSD. We were looking at blood glucose levels, and we had people whose numbers were just bananas, some really, really high outliers. And so we had to like truncate our data set essentially and look at anybody who had a z-score of a certain amount. We had to remove, we had to write this up, of course, but we were just like, we can't use this data because having a normal distribution for your data is an assumption for a lot of statistical methods. And when you have huge outliers, you break that. In fact, I think we're going to have assessing normality right after this, so we can chat about it then.